Hello and welcome to today's lesson. We're going to be talking about what the difference between an independent and dependent event is and how that difference changes which numbers we use to calculate the probability of those events. So as we're going through this lesson, please make sure that you take good notes. I give you some definitions and notes at the beginning. Make sure you copy those down so that you have them to reference when you're studying later. And you can even pause the video and rewind if I start going too fast for you. And you can even pause at the beginning of a question, work that problem out yourself, and then watch the video to see if you get it right or wrong. And especially when you show all of your work, and I show all of my work, you're able to pinpoint exactly where it is that you went wrong, or you're able to see that you did things exactly right, and that can give you a gauge on how much and where you need to be studying and save you a little bit of time. So I'm so glad that you're joining us today, and let's go ahead and take some notes.
First, let's look at the difference between an independent and dependent event. An independent event is when the probability of the second event is not affected by the first event. So like flipping a coin multiple times, each flip of a coin doesn't affect the last one. And then drawing a card, replacing it, and then drawing another. Because you put that card back in the deck, what you drew the first time doesn't affect what you draw the second time because that card's back in there. So anytime you see replacing, that's most likely an independent event. And what are dependent events? Is when the probability of the second event is affected by the first event. So you draw a name from a hat and you keep it out, and then you draw another name. So if you do not replace it, you keep it out, that's going to be a dependent event. So in all of these problems, we're calculating the theoretical probability, and the way that you find a probability is taking the number of times the event happened that you're trying to find the probability for over the number of outcomes. And when we are looking at multiple events, whether they're independent or dependent, we need to know how to find the probability of them both happening, or of all of those events happening, whether it's two or more. And so that we're going to use the fundamental counting principle, which tells us that you are going to multiply those probabilities together to get the probability of them both happening, or all three of them happening. Let's go ahead and look at our first example. It says, which pair of events include one event that is dependent of the other? So we're looking for a pair of events that are dependent. So the three are independent, one is dependent. So A, rolling a die and tossing a coin. Well, those are independent. They don't affect each other at all. So it's not going to be A. B, drawing a blue marble out of a box, replacing it, and then drawing another blue marble. Because it was replaced, that makes it two independent events, so it's not B. C, rolling a die and then rolling a die again, getting the same number. When you roll die back to back, what you roll the first time doesn't affect what you roll the second time. So it's still going to be C, because you have a 1 out of 6 chance of getting each side each time, no matter how many times you roll. So it can't be C, so let's look at D. Drawing a red marble out of a box, not replacing it, and then drawing another red marble out of the box. Because it's not replaced, that makes it dependent, which is going to make D your final answer. This problem says, Jared's teacher has a box containing 3 orange marbles, 7 blue marbles, 5 purple marbles. The probability that Jared will randomly draw an orange marble and then a purple marble without looking is 1 out of 15. Using this probability, determine if the event of a drawing of an orange marble and the event of drawing a purple marble was independent, dependent, both, or neither. So once again, it can't be both or neither. So A and D are automatically out. So what I'm basically looking is if it was dependent, the marble was not replaced the second time, and if it's independent, it was replaced. So I just need to calculate the probability of both of those. So first let's do B, it not being replaced. So I'm looking at drawing an orange marble first and then drawing a purple marble. So there are 3 orange marbles. So the first time I'm drawing, I have 3 chances out of, and then I need to add those up. 3 plus 7 is 10, plus 5 is 15. So there's 15 total marbles in that bag. So he has a 3 out of 15 chance of drawing an orange marble the first time. Now, if that orange marble is not put back in, then there are 14 marbles left in the bag total. And now we're looking at a purple marble. So I know that there are 5 purple marbles in the bag. And so since the orange one is sitting out, there's still 5 purple marbles in there. So that means that the 5 isn't going to be reduced this time, just the denominator. And so I go ahead and multiply those out, and I get 1 out of 14 as my probability once it's reduced. That's not the same as 1/15. So that means it's not going to be dependent. It's probably going to be independent. But I want to go ahead and check that to make sure I didn't make a silly mistake with the first one. So I want to make sure I really know what the right answer is. So if it was replaced, I'm still going to have 3 out of 15 chances of getting that orange marble the first time. But if it's replaced, I have 15 marbles in the bag the second time. And there's 5 of them are still purple. So this time I'm going to multiply 3 over 15 by 5 over 15. And once that's reduced, I get that 1/15 that I'm looking for. So that does mean for sure that C is going to be my final answer. So here, a game requires a person to roll 1 die and then another. Assume that the first die rolled lands on 5. Which of the following events is independent of the fact that the first die rolled was a 5? A says that after the second roll, the total combined number is 6. So because you're combining for the sum of the first roll and the second roll, those are going to be dependent. So it's not independent, so it's not going to be A. And then B is the number on the second roll is less than the number from the first roll. So because you're comparing the total of the 2 rolls, you're comparing their sizes, that's going to be dependent also. The C says the second die rolled is 1. So the outcome of the first roll and the outcome of the second roll, they don't affect each other at all. So the C is the one that's going to be independent. And let's just check D real quick to make sure that we didn't make a silly mistake. D says the number on the second roll is more than the number on the first roll. So once again, because you're comparing more than, less than to the outcomes of your second and first roll, it can't be D. So C is my final answer. Looking at number 6 here, Erica was out of town for a month, so she had her friend Sarah check her mailbox. Each day, Sarah would count how many different types of mail Erica received and then place the mail in a box inside Erica's apartment. The table below shows how many pieces of each type of mail Erica received during the month. According to the table, if Erica drew 2 pieces of mail randomly from the box without replacement, what is the probability that she would draw out 2 advertisements? So the key words here is without replacement. So she's looking for 2 advertisements. So her first draw, there's 40 advertisements in the pile. Out of how many? Well, this one here doesn't give us the total. But if you add 20 plus 8 plus 24 plus 4 plus 40 plus 4, you're going to get 100 pieces of mail. So 40 out of 100 is the first probability. And then we're going to multiply that times the second probability. But because she didn't put that back in, we now have to say there's only 39 advertisements in the pile out of 99 total pieces of mail, because she took that first one out. And that's how, when you have dependent events, you have to keep that in mind when you're writing that second probability. You have to think, do I need to subtract something from my total, or do I need to subtract something from the number of pieces that I have in the top? And sometimes you do both, sometimes you just do one or the other. Typically, you always subtract from the total. It's the numerator that you may or may not need to. You have to think it through. And so before I multiply these, you can simplify the fractions if you're doing it by hand, or you can just put it in the calculator and let it do it for you. But when you do multiply these, you're going to get that it equals 26 over 165. And that's going to be your probability, which is choice C. This question here says Jillian numbered 10 counters from 1 through 10 and placed them in a cloth bag. Then she performed an experiment where she drew one counter, recorded its number, and then replaced it. Jillian did this 25 times. The results of Jillian experiments are shown in the table below. So I'm just going to write a total of 25 here so I don't forget, since it already told me. It wants to know, what is the experimental probability of drawing a number 8 counter followed by a number 4 counter? So these are independent events. So I don't have to think about subtracting any numbers from the total or the numerator. That's not going to happen because they're independent. It's going to be replaced. So I have to think, okay, what is the probability of drawing an 8 counter first? So an 8 counter was drawn 3 times. So that happened 3 times. So that's going to be my numerator out of 25. So total goes in the bottom times. How many times was the number 4 counter drawn? If you look at my table, it was also drawn 3 times, so it's going to be a 3. And because it was replaced, there's still 25 counters in that bag. So it's going to have a denominator of 25 also, because these were independent events. So when I multiply those two fractions together, I get 9 over 625, and that doesn't reduce at all, so that's going to be my final answer, which is D. Okay, this question here says the spinner below has 8 equal sized sections. Using the spinner above, what is the probability of landing on a blue section on the first spin and then landing on a yellow section the second spin? So there isn't any dependence here. They're independent events. So whatever you spin the first time doesn't affect what you spin the second time. So we're going to look at how many blue sections there are. There's 1, 2, 3 blue sections. So he has a 3 out of 8 chance, since there's 8 total sections, to land on a blue on his first spin. He's looking at the yellow sections for his second spin. So there's only 1 yellow section out of 8, so he has a 1 out of 8 chance of spinning yellow the second time. And so we're going to go ahead and multiply 3/8 times 1/8. And when I do that and reduce my fraction, I end up with 3 out of 64, which is choice B, my final answer. This question says there are 3 yellow marbles, 4 blue marbles, 5 red marbles, and 2 green marbles in a bag. 1 marble is drawn from the bag at random and replaced. Then a second marble is drawn. Which of the following has the greatest chance of occurring? So we need to note that this says replace, so that's going to be independent events. And then I just need to calculate the probability of each of these choices. So A is drawing 2 red marbles. So there are 5 red marbles in the bag. So the first time he has 5 chances out of, and I need to find out how many total marbles there are in the bag. So when I add together the 3, 4, 5, 2. That gives me a total of 14. So there's 14 marbles in that bag. So he picks that one and he puts it back. So that means the second time there's still a total of 14 marbles in that bag. And there's still a total of 5 red marbles in that bag. So the probability doesn't change at all because they're independent events and both red marbles. And so when I go ahead and multiply those two fractions and then reduce the fraction, that's going to leave me with 25 over 196. And so then I just need to do the same thing with B. What's the probability of drawing one red marble and then a yellow marble? So I know that there are 5 red marbles out of 14 total marbles. And then I know that there are 3 yellow marbles out of total of 14 because they were replaced. So I'm going to multiply those fractions and I get 15 over 196 this time. So far A is bigger. So let's go ahead and look at C. C, I'm looking at 1 green marble and then 1 blue marble. So I know that there are 2 green marbles, so that's going to be 2 over 14 times, and I'm looking at the blue marble, there's 4 of those, so there's 4 out of 14 chances of getting a blue marble. The denominators stay the same here because they're independent events, and when I multiply those numbers, I get 8 over 196. So A is still in the lead, still the biggest probability. And then I'm going to go ahead and do D, the probability of drawing 2 green marbles. So there's 2 green marbles in the bag out of 14. And that doesn't change for the second one because he put that back. And so here, when I multiply these fractions, I get 4 out of 196. And so the biggest probability here is A. And so A is going to be my final answer. Thank you for joining us today, and I hope you learned something new.